Your house. Let's talk about your house. Your house does not use the same kind of electricity that is used in your car or in a flashlight. The electricity we've been talking about has been direct current. That is direct current where electrons are flowing through a circuit, right? Direct current, electrons are flowing, so you have a current flow through this circuit. Even when you have a parallel device, it's just current flowing. Your house doesn't work that way. Our houses use what's called AC, alternating current. So your car, little devices you have, they use direct current. There's a battery where you have current that flows. In your house, in industrial applications, it uses what's called AC, alternating current. So don't think that your house is DC, right? It is not. It's AC. What you have is you have these big power plants, right? They burn coal or whatever. They have these turbines that turn. They turn, and in those turbines there's magnets, and that generates electricity. Well, they turn at a very specific rate. In the United States, it's 60 hertz. You may have heard things, oh, 60 hertz, or you'll have devices that'll say, oh, this device works between 50 and between 50 hertz, and there's some hertz. The electricity goes back and forth. You're saying, what? Electricity goes back and forth? Yeah, it goes back and forth. Those big power lines that's going through, the electricity is actually kind of going back and forth, back and forth. Now, it doesn't matter. When your light bulbs, if the electrons, when you're lighting your little filament in your light bulbs, it doesn't care that the electrons are going back and forth. It's still going to heat up the light bulb. Can you see that? But what happens is it goes back it's important at the 60 hertz. If you go to Europe, some devices won't work at 50 hertz, right? Like if you buy a drill in the United States, that drill, you buy an electric drill because you're going to drill holes, you're building something, right? That motor inside the drill is made for USA, where that electricity comes from the power plant. It's going at 60. So the motor's designed that it spins because of 60 hertz. If it gets a different hertz, it's not going to spin right, it's going to overheat. So in the United States, we have alternating current in your house. The electricity goes back and forth. It's because of the way inside power plants you have these big generators. They spin, and it's more efficient. Direct current doesn't work when you transmit it over long distances, but alternating current, the voltage stays the same. So for now, we're not going to go into why. It's a little bit complex, but when you're sending current over a long distance, the alternating current is better. It travels much more efficiently. Okay? So it goes back and forth. So in your house, all we're going to worry about now is that it's an alternating current. Okay? So direct current, let me make this bigger. Make sure you can see it. Yeah, so in your house, in your school, in factories and stuff, okay, when you plug something into your house, right? So, you have a normal plug. You have a normal plug in your house, right? Like, I'll show you a normal plug in a house. There's a plug in a house right there, okay? So my camera uses AC. That's the plug for my AC camera, right? That's a normal plug we've all seen, right? So we have a normal plug in a house. Felix, where are you? Well, I'm located at parts unknown, right? That's where I am right now. So if anybody asks, where's Felix? He's in parts unknown. All right. So in your house, it's alternating current. You may have heard AC/DC, right? That's a famous band. They're old now. Maybe there's to you it's like this ancient band. They probably are, right? AC/DC, right? So AC current, alternating current. DC means direct current. Now AC/DC, I think they had different connotations, but alternating current, direct current. Direct current implies that current flows in a single direction. from the positive terminal to a negative terminal. Alternating current continually reverses its direction. It flows in one direction to another. You're going, what? That sounds crazy. But that's the way everything works. 60 hertz. So that means 60 hertz means that in 1 second, it's gone back and forth 60 times. That's what hertz is. In 1 second, it's gone back and forth 60 times. It's like this. So you have, here we're having current, right? And then this is time. So the current is positive, then it's negative, positive, negative, positive, negative. This is the way current flows in your house. It goes positive, negative. In 1 second, it's gone positive and negative 60 times. So it's a smooth, it's not like it's not a jerky thing. It's a very smooth. And then if you buy an electric drill, well, the motor in the electric drill, the windings are spaced in such a way that it smoothly takes the positive, it starts turning it, then the negative comes in, it turns it, then the positive comes in, it turns it, then the negative turns it. The windings in an electric drill or an electric saw, power tool, right? Your power tools, or a blender, right? You're making, I don't know, what's some crazy kind of blending thing where you throw carrots and kale, I don't know, this is California, right? And your blender. Well, the motors here, so they spin very smoothly because they get the positive and negative. Physically, the windings in that motor are spaced. If you take those motors to Europe, they're going to get hot. They may not even work because there they use 50 hertz. And so it's not going to be efficient. You have to buy different devices there. So this is the way things work in America. Okay? Right, a sine curve, a sinusoidal curve. Anytime there's a curve like this, right, they call it a sinusoidal curve. So the power is still dissipated. If you have a light bulb in a circuit, the power still gets dissipated, right? And here they're talking about an effective RMS, which is 0.707. We're not going to get into that. That gets a little bit too complex. This is the tail end of the chapter. But it's a good thing to know, to be exposed to that. That's right. And so in the States, our voltage is rated as typically between, right, 110 and 120 volts. You buy something, right, everything that we have is 110, 120 volts. If you go to Europe, things are usually 205 volts, a much higher voltage, right? So different countries, that's why if you go to different countries, you have to have different devices. You got to buy adapters for your stuff, right? In the United States, so typically the voltage is 115 volts and it's a alternating current back and forth at 60 hertz. That's what we use here in the United States. And then here's just a little problem. Oh, let me go back to that one. This is actually a good one to look at. Okay, a 60 watt light bulb, so a normal 60 watt light bulb is designed to operate on 120 volts AC. So this is an American light bulb. You would turn it in. What is the current? Well, here you go. So it would just be the power is equal. Now here they use a delta V. Don't worry about that. Power is equal to your current times your voltage. That's what I told you. Here's what I wrote down. Power is equal to your, here I wrote voltage times your current, right? Power. So your current is just your 60 watts. If you have a 60 watt light bulb and divided by 120 volts going into your house, that light bulb is using half an amp, 0.5 amp. Ta-da! Isn't that cool? Physics. No longer are light bulbs a mystery. How does the light bulb work? You folks know how. You know, there are people that are big shots in companies and think they're all that. You know more than they do. And you do, for real. Okay, let's go down. What is this one here? And they're just showing, in your house, everything is in parallel. Kind of like your car. So the voltage is the same, right? You have a lamp you want to plug in. Well, your lamp needs the 120 volts, right? Your toaster needs 120 volts. Your TV set needs 120 volts. Everything that plugs in. So your house, everything is wired up in parallel. Can you see that? Everything is wired up in parallel. So then this is to the main line. So this is just there's a two prong in a plug. That's what this is showing. Your plug has two prongs, right? And then your house has circuit breakers. If a device breaks and it's shorting out, well, then you'd have to go to your garage or your other room. There's a panel on a wall where it's just devices where if the current gets too high, it opens. It's a safety device. In the old days, houses would burn down all the time, right? Now we have these circuit breakers. Or we had an old house when I was a kid, we had fuses. It was a thing that would, if too much current, it would burn out. You'd have to go put a new fuse in, right? Okay, so household circuits are wired in parallel so that different appliances can be added or removed from the circuit without affecting the voltage. Remember, if it's series, your voltage keeps changing. That's why you don't use series. That's why power companies, in the early days, Edison and Tesla actually had a big argument. Edison wanted to use direct current. Tesla said no, AC is better. Of course, Tesla won. Although Tesla died poor, Edison died a billionaire. So, because he was more ruthless. One was the better scientist though, so keep that in mind. Okay, so that's it. And now you know a lot about circuits and how electricity works. It's the flow of electrons. You know direct and parallel circuits. You know AC and DC. Okay, folks, so everyone stay safe. And this was chapter 13. Make sure you read the book. All the PowerPoints are up online, and take care.